Hello class and welcome to lesson 2.0. I just wanted to let you know that we're starting unit 2, which is called coordinate geometry. So in your notes, if you want to make a title page or a division or a divider, whatever you need to do just to separate your units, that would be recommended by me, so that when you start studying for your final exam, you have each unit separated into different sections and it's organized. Remember folks that your notes are your tool to help you be successful, so why not set them up in an organized manner? Awesome. Okay, so since we're taking a look at coordinate geometry, let's just take a look at a couple definitions and see if you guys can remember this. So for the warm-ups, number 1, define parallel lines and draw an example to help explain this. Okay, so think about that. Number 2, define perpendicular lines and draw an example to explain this term. Okay, and the third one, what is the formula for Pythagorean theorem and when to use it? Draw a diagram explaining this formula. So ladies and gentlemen, instead of actually doing the answers to the warm-ups, this is going to be part of our lesson today. Okay, preparing for the chapter means we're going to review stuff that you should already know, which hopefully are these 3 topics. So I'm going to flip the page and we're going to get started. So write down today's lesson 2.0, prepare for the chapter, and we're going to take a look at parallel lines. Okay, definition of parallel lines are lines in the same plane that do not cross or intersect. Usually you see them with little arrows to show you parallel lines. That's the short form for that. And does anybody remember what we know about parallel lines and their slopes? So if we take a look at this diagram here, we've got line AB and line CD. They look parallel, but we got to figure out how to prove that. Okay, so what we're going to do is we're going to take a look at AB first. We're going to draw our little triangle. And now, folks, since we've got labels on our endpoint, A and B, we're going to go slope, and in lowercase, we're going to go AB. So lowercase m and then subscript AB. So slope of AB equals the rise over the run. So our rise in this case is going to be 1. So I'll put rise over run. Put down my formula at least 1. Okay, and it's going to be 1 over 4. All right, let's take a look at our second line, CD. Again, we do the same thing, M, but in this case, we're going to go with CD. So slope of CD equals rise over run. And that equals 1 over 4. So what do we notice about lines that look parallel in terms of their slopes? Hopefully you've got this one figured out, folks. Parallel lines, or slopes of parallel lines, are equal or the same. Okay? Remember, by definition, they will never cross or intersect, and they have to have the same slope, otherwise they will cross or intersect. Great. So there's a refresher on parallel lines. Let's move to the next one, which is perpendicular lines. Perpendicular lines are lines in the same plane that meet or intersect at 90 degrees. Probably should recognize this short form here with a little, it's a T with a little box in the corner. That box represents the 90-degree angle. Okay, and that's going to be familiar for you when we deal with trigonometry as well. All right. So they meet at or intersect at 90 degrees. Now you may remember from grade 9 the rule we learned about the slopes of perpendicular lines, but if you forget, we're going to take a look at calculating the slopes here and see what we can come up with. So first of all, do the slope of AB, which is the green line. Okay, so slope of AB equals rise over run. Okay, in this case, we have, ladies and gentlemen, if I draw my box, I'm going to rise 2 and I'm going to run 6. So it's going to be 2 over 6. Please don't forget to put in the lowest term, so it's going to be 1/3. Okay, and let's take a look of slope CD, the blue. So I'm going to take a look here. Again, formula is slope of CD equals rise over run. And when we take a look at this, folks, be careful here. I'm not actually rising, I'm falling, so it's going to be -3 and 1. All right, so let's take a look at these two slopes and compare. One slope has a value of 1/3. The other one has -3/1, which I would simplify, ladies and gentlemen, to -3. But I circled those two so that you can hopefully see the relationship between them. Look at the fraction. Notice that they're flipped and they have a different sign. So hopefully you remember these two words, that perpendicular lines are slopes of perpendicular lines, my fault, sorry, are negative. That means you switch the sign. And reciprocals, hopefully you remember that terminology. I know when you did your EQAO, they were looking for those words. Okay? And what does that really mean, in case you forget? You flip the fraction and change the sign. Okay? We'll do a couple examples down here just to make sure you're on the right track. Move it up. Example 2, state the slopes of the lines that are perpendicular to the following. So first of all, AB has a slope of -2. Okay? So you're going to say M equals -2, but I want to make that into a fraction so I can flip it. So remember, a whole number, to make it a fraction, becomes over 1. And then to do slope perpendicular, we use a little short form for perpendicular. Slope perpendicular equals, flip the fraction, so it's going to be 1/2, and change the sign. Okay? Perfect. Okay? So you could have that, or I would like to see slope perpendicular of AB equals 1/2, if you want proper communication. Yeah. Take a look at the second one, ladies and gentlemen. We have slope of MN equals 4/3. So slope perpendicular of MN equals, so start by flipping the fraction, so it's going to be 3/4, and you change the negative to, I apologize, it's a positive, so you change it to a negative. Awesome. Now, this third one's a little tricky. Let's see if we can figure this one out. EF has a slope of 0. That's one of your 4 special types of slopes. Hopefully you recognize that that's a horizontal line. Okay, so M equals 0. That looks like this, straight across. Okay, if we want something to intersect 90 degrees, it's going to be looking different. So M perpendicular, that's going to equal what we call a vertical line. And we have to talk about the slope of a vertical line. Do you remember what it's called? Okay, so slope perpendicular equals undefined slope. Okay. So I'm just going to do one thing, folks. It's the vertical line that we're switching to, but M perpendicular is the undefined. So just correcting my communication there. All right, any questions about perpendicular? Come and see me in class. Last topic today is Pythagorean theorem. Okay, so the formula, ladies and gentlemen, is c squared equals a squared plus b squared, where c is the hypotenuse as the longest side of a right triangle. You have to have a 90-degree angle in order to use Pythagorean theorem. Okay? And folks, I want you to remember that although the hypotenuse is the longest side, it's also great to remember that it's opposite the 90-degree angle. So I want you to put that in there. Opposite the 90-degree angle. Okay? Great. Now there's 2 different ways we can use Pythagorean theorem. One is if we're looking for the hypotenuse, which is, in this case, short form hyp, HYP. So that formula we use when we are finding the hypotenuse. We ask to find it. Okay? What if the hypotenuse is given, though, and you need to find another side? Okay? We're going to rearrange that formula, so it's going to look like a squared equals c squared minus b squared. And this is when hyp is given, and you're going to find another side. So hyp is given. Therefore, find other side. So I ran out of room there, guys. Okay? All right. And when do we use Pythagorean theorem? When you need to find the third side of a 90-degree or right triangle. Awesome. All right, let's do 2 examples, see how we can use this formula, and then we're off to doing our homework already. So example says find the missing values. So for A, we got to find x. Taking a look at x, ladies and gentlemen, is x the hypotenuse? Yes, it is. So you're going to go x squared equals the sum of the other 2 sides squared. So 2 squared plus 5 squared. Now, this is grade 10, folks. I don't need to see the initial formula. You can sub it in right away. Take your calculator, ladies and gentlemen, and plug in your calculator what 2 squared is plus 5 squared. Put it all together. So add them together, and you should get 29. And then don't forget, folks, in order to get x by itself, you got to take the square root. Okay, so plug in your calculator. We'll round to 1 decimal place. For lengths, 5.4 meters. Okay. Question B. Okay, a 10-foot ladder is leaning against a tree 7 feet up the tree. How far is the base of the ladder from the tree? So first of all, ladies and gentlemen, I know I'm going to need a little bit more room here, so I apologize. Just let me try and get this moved down a bit lower. Oops. Let me try something else here. I'm sorry, guys. Give me 1 second. I'm just trying to fix this up. So we've got room here. There, that's better. Move that down for you. All right, so let's focus on this. Let's see what happened. Somehow I lost my wording. I don't know where it went, guys. Let's edit undo that and see what happens. That's funny, isn't it? I'm sorry. Okay, we'll just leave it as is, and I'll do the rest of the work below. My formatting, something's wrong with it. Okay, guys? Sorry about that. All right, so here we go. A 10-foot ladder is leaning against a tree, so we've got to make an assumption here. We've got to make an assumption that the tree grows 90 degrees on the ground. Okay, so this is my tree. Okay, and then here's my ladder shooting up. Okay, and it says it's a 10-foot ladder, so I put 10 feet on that, and it's shooting up the tree 7 feet. And we make an assumption that it's 90 degrees in the triangle. Okay. Now the question says, how far is the base of the ladder from the tree? Well, that's going to be our unknown, and we'll let that be x. So whenever we draw a diagram, we introduce a letter, we have to do a let statement. So let x represent ground distance. That's fine. Or distance between ladder and tree base. That's fine. Okay. And what I want you to notice here, folks, is that the hypotenuse is given. So we're finding another side. So what we're going to do is say x squared, the side we're trying to find, equals 10 squared subtract 7 squared. Now, I don't want you to panic, folks. I want you to think maybe your teacher last year said it's the hypotenuse squared equals the sum of the other 2 sides squared. You might be more familiar with this. All I'm doing, folks, is isolating x squared. Currently, 7 squared is being added to it, so I'm just taking it and subtracting it from the other side. So I'm just saving a step if you're wondering where that's coming from. Okay? I just like to get my variable isolated right away. All right, keep working here, guys. So let's plug it in our calculator. 10 squared minus 7 squared. Plug in your calculator, and you should get 51. Okay, and then don't forget to take the square root. So x equals 7.1 rounded. And what do we got to be careful with here, folks? This is an imperial question, which means it's dealt with feet. And what do we notice about this answer? You cannot have decimals. So just write that down here. Imperial units. can only be expressed in fractions. Metric can only be displayed in decimals. So what we want to do, folks, is we want to take a look here and say, hey, a couple approaches you could say is we know we've got 7 feet, okay, and then 0.1 is 0.1. If you could take your calculator and go 0.1 times 12. So just give me a second, I'll plug that in my calculator, because there's 12 inches in a foot, so that's what I'm trying to figure out how many inches it is. Okay, so you could say it's 7 feet 1 inch. You could say that for an answer. Or you could change 0.1 into, you could also have x equals 7 1/8 foot. Okay, so it's up to you. And then we just do a therefore statement, folks, to finish off. Sorry, I ran out of room. So therefore, the ladder base is, I'll go 7 1/8 foot from the tree. Just remember, for word problems, folks, you need to, if you're drawing a diagram, introduce a letter, write a let statement, show your work, and then don't forget your therefore statement with the units. Okay? All right, folks, here's your homework. Page 68, numbers 2 to 6. For number 6, you may wish to cross multiply, if that is easier for you. Just remember, cross multiply is something like this. So if I had x over 5 equals 2 over 9, if I cross multiply, folks, just take the cross that has the variable in it. So x times 9 is 9x. Equals the other cross, so 5 times 2, which is 10, and then we need to get the variable by itself. So currently x is being multiplied by 9, so you do the opposite, which is divide, and so x equals 10 over 9. And just leave it as a improper fraction as long as it's in lowest terms. Okay, folks, have a great day, and of course, come and see me if you need any help. Namaste.